CimTrak has the ability to trigger specific policies in ZPA based on violations detected by CimTrak. Now, this helps automate security and access when things are not right. There's two trigger types: integrity and compliance. Integrity triggers are for when CimTrak detects changes to your files, folders, registry keys, servers, workstations, firewalls, and more. Compliance triggers are for when these systems are no longer hardened based on CIS benchmarks or DISA STIGs, or even against many compliance frameworks we support. Now let's see how it's configured. When you create an integrity monitoring policy, we have the ability to add on the Zscaler integration. We can choose if we want to integrate with our access policies, isolation, or client forwarding policies. Now this lets you build your own rules. Let's say in this case, if a unknown change occurred, or maybe if a deny list item was found, or if an item that is not in my allow list was added to a system. In this case, let's just say it's an unknown change. Then let's trigger one of my isolation policies. Now you'll see this is pulling down from my environment. These are the rules I have set up in my ZPA. Now I'll select the Splunk server in this example, but this could be setting up an isolation policy for a website, another HR tool, a server, whatever it might be. And in this case, I want the read-only mode on and isolation when it turns on. And if we're in a good state of integrity, just leave it in bypass mode, let them in. Now this rule will translate in, and you can add additional ones if you'd like. Now let's see what it looks like when this is set up. So here we are on the Splunk server, which is a Linux host, and let's make some changes to some important files. And we'll just completely ruin it, delete a bunch of lines out, change this setting, and save it. Now let's head back to CimTrak to see what it detected. Back in the CimTrak logs, we can see the detections. We can see the file was modified, the path, the user, the process, the normal forensics. But something else happened right after that, and we can see that the isolation policy I set up has been triggered. If we go look at ZPA and do a refresh here, we'll see that that policy went from bypass, and now it's in isolation mode. Now if we go try to access that Splunk server, look what happens. It loads up in a sandbox in isolation mode. It prevents any nefarious files from being loaded onto my system. I can't interact with it. I can see it's there. I can see the server's running, but clearly something is wrong, and it's preventing damage, mitigating risk. I can't even put my credentials in here. Now let's take that same concept to our compliance policy. This is where the compliance trigger comes in. We can trigger specific ZPA policies based on violations from CIS benchmarks, DISA STIGs, or other compliance frameworks that we support. If we scan a system and it's no longer hardened anymore, like it has been the last 90 days, that's a problem. And now we can automatically enable those isolation policies, access policies, client forwarding policies right away, just like we saw in the integrity monitoring policy example. However, there's one more key piece here. If CimTrak sees it get back into that hardened state that the user configures, we can automatically undo that policy, disable that isolation policy, for example, and get you back to normal without any human interaction. These triggers really give the user the power to automate security and access, mitigate damage, reduce risk, and assist in remediation. If a system isn't hardened anymore, should people be accessing it? If a keylogger was added or critical files were infected, is your production environment safe anymore? CimTrak can provide the awareness to these deviations, integrate with Zscaler to restrict access automatically, giving you the ability to safely remediate.